You do this every morning. You wake up, you reach for your phone, you check the time, the weather, maybe the news. The screen lights up in your face and you don't think about it for even a single second. You should, because that screen and everything behind it runs on a system so fragile that a single event, one that has already happened before and will happen again, could erase it, not damage it, not slow it down, erase it. And the part nobody tells you is this: the warning signs are already there. Right now, somewhere above your head, 93 million miles away, a star is doing what it has always done. Churning, rotating, building magnetic pressure in its outer layers until that pressure becomes unbridgeable and releases. The sun fires off plasma and radiation at speeds exceeding 4 million miles per hour. Most of the time, it misses Earth entirely. Most of the time. Call this the Solar Exposure Index, personal framework for measuring your actual vulnerability, not your perceived one. It has 3 layers. Layer 1. How many of your critical daily functions depend on satellite or grid infrastructure? Layer 2. How many hours could you sustain those functions without external power? Layer 3. How long before the absence of those functions becomes medically or financially dangerous for you personally? Most people, when they walk through that index honestly, bottom out at layer 2 within 6 hours. 6 hours. The National Oceanic and Atmospheric Administration, NOAA, maintains a real-time space weather prediction center in Boulder, Colorado. It is staffed 24 hours a day, 7 days a week, because the threat it monitors does not keep business hours. In their published risk assessments, a Carrington-level geomagnetic storm, the benchmark event in solar storm science, is classified as capable of inducing ground currents strong enough to permanently damage high-voltage transformers across entire continental power grids. Permanently, not a blackout, a structural collapse. The difference matters enormously. A blackout ends when the power comes back. A structural collapse ends when you replace the hardware. And the largest high-voltage transformers in the American grid are custom-built, manufactured in limited quantities, and carry lead times of 12 to 18 months per unit. There are approximately 2,000 of them in the continental United States. The country keeps fewer than 400 spares. Here's the first number in the countdown. And the countdown only goes in one direction. September 1st, 1859. Richard Carrington, a British amateur astronomer, was sketching sunspots through his telescope when he witnessed something no human had scientifically documented before: a white light solar flare, the largest ever recorded. 17 hours later, the resulting geomagnetic storm hit Earth. Telegraph systems across North America and Europe failed simultaneously. Some telegraph operators reported receiving electric shocks through their equipment. Others reported that telegraph lines, completely disconnected from their power sources, continued transmitting messages on their own, powered entirely by the induced electromagnetic current from the storm. In 1859, the most sophisticated electrical infrastructure on Earth was telegraph wire. That was the only reason civilization survived it. The same event today would hit a world running on 6.4 billion smartphones, 2.5 billion internet-connected devices, and a power grid whose total replacement value the American Society of Civil Engineers estimated in 2021 at over $5 trillion. $5 trillion. 18 months minimum. No contingency plan at national scale. This is not a theory. This already happened. And then there was Quebec, March 13th, 1989. A geomagnetic storm, far smaller than the Carrington event, rated X15 on the modern solar flare scale compared to what scientists estimate the Carrington event would measure today, hit the Hydro-Quebec power grid at 2:44 in the morning. Within 92 seconds, the entire provincial grid collapsed. 6 million people lost power, not for hours, for 9 hours. Transformers failed. Surge protectors were overwhelmed. The cascade moved faster than any human operator could respond to it. Hydro-Quebec later estimated that the induced geomagnetic currents were equivalent to detonating a 2,000 megaton electromagnetic pulse directly above the province. And that storm, by the standards of what the sun is capable of, was moderate. Moderate. Now move forward. Move to Sweden. October 2003. The Halloween solar storms, a sequence of X-class flares that NOAA classified as among the most powerful of the modern satellite era, knocked out power across parts of southern Sweden for approximately 1 hour, and damaged satellites in low Earth orbit used for GPS navigation, weather forecasting, and communication. Air traffic control in parts of Europe was disrupted. The FAA in the United States issued warnings to pilots about potential navigation failures. 1 hour of disruption from a storm that did not even approach Carrington-level intensity produced cascading failures across 4 critical infrastructure categories simultaneously. 4 systems, 1 storm, 1 hour. Scale that to 9 hours, scale it to 9 days. Scale it to the mathematical reality that NOAA's own models give a Carrington-class event a 12% probability of occurring within any given decade. which means in a 50-year period, the cumulative probability of experiencing one exceeds 50%. You're more likely than not to live through an event of this magnitude. That is not alarmism. That is published probability science from a federal agency. After spending time reviewing NOAA's Space Weather Archive, cross-referencing it with the Federal Energy Regulatory Commission's 2012 report on geomagnetic disturbances, which explicitly warned that a Carrington-level event could permanently damage between 300 and 500 high-voltage transformers in the United States alone, and then walking through a major hardware supply chain for high-voltage electrical components in the American Midwest, one thing became undeniable. There is no national replacement plan. Not a slow one, not an underfunded one. There is no plan. The FERC report was published in 2012. The grid vulnerability it described has not been meaningfully addressed in the intervening years. The transformers it flagged as most exposed, large power transformers, or LPTs, operating at 345 kilovolts and above, remain the most difficult to replace, the least stockpiled, and the most critical single points of failure in the entire American electrical infrastructure. A single point of failure. In a system that 335 million people depend on for heat, water, food, refrigeration, medical equipment, and communication. Here is what connects all three events, Quebec, Sweden, 1859, into a single, terrifying architecture. Each one was a different magnitude. Each one hit a different level of technological civilization. And each one revealed the same structural reality. Modern electrical infrastructure does not fail gradually under geomagnetic stress. It fails catastrophically, nonlinearly, and faster than any human response system can compensate for. The technical term for this is a cascading failure, a condition in which the failure of one component increases the stress on adjacent components until the failure propagates through the entire system faster than it can be isolated. Engineers who study grid resilience use a specific threshold concept called the N1 criterion, the idea that a grid should be able to sustain the loss of any single component without collapsing. A Carrington-level geomagnetic storm does not trigger N1. It triggers N- everything simultaneously. That distinction is the entire story. In 1989, a physicist named Dr. John Kappeman testified before Congress about geomagnetic storm risk to the American power grid. He brought models, he brought data, he brought specific transformer vulnerability maps. Congress thanked him and moved on. He continued publishing, he continued warning. His 2010 study, conducted for the Oak Ridge National Laboratory, concluded that a Carrington-class storm could leave between 130 million and 300 million Americans without power for a period ranging from months to years. Not because the electricity was gone, but because the physical infrastructure to generate and distribute it would be structurally destroyed. Months to years. His work was called speculative by utility industry representatives in subsequent hearings. His numbers were called extreme. In 2019, the Department of Homeland Security's own risk assessment, Executive Order 13865, signed in March of that year, specifically to address electromagnetic pulse threats, validated virtually every structural vulnerability Kappeman had identified almost a decade earlier. He was right. They had time to prepare. They did not prepare. So here is what the person watching this does today. Not next week, not after the next news cycle. Today. First, identify the 3 devices in your immediate environment that you would lose complete situational awareness without. For most people, that is a smartphone, a router, and a computer. Price a Faraday bag, a signal blocking enclosure that also provides electromagnetic shielding for each of them. They cost between $20 and $60 each. Buy them. Second, locate the nearest AM radio station that carries no weather radio broadcasts in your area. AM radio, unlike FM, unlike digital streaming, unlike satellite, operates on long-wave frequencies that are significantly more resistant to geomagnetic disruption. A hand crank or battery-powered AM receiver is your minimum viable communication device in a grid-down event. It costs less than $30. Third, calculate your household's water dependency. The average American uses 80 to 100 gallons of water per day. Municipal water systems depend on electrically powered pumps. If the grid goes down for more than 72 hours, water pressure in most municipal systems begins to fail. Store a minimum of 1 gallon per person per day for 14 days. This is not extreme. This is what FEMA's own published guidelines recommend, and it is a guideline that fewer than 20% of American households currently meet. Fourth, if anyone in your household depends on electrically powered medical equipment, oxygen concentrators, insulin refrigeration, CPAP machines, powered mobility devices, contact your utility provider today and register as a medical baseline customer. Most utilities maintain priority restoration lists. Most people who qualify for them are not on them because they never asked. These 4 steps cost less than $200 total and less than 2 hours of time. That is the entire distance between being prepared and not being prepared. The sun will do what the sun does. It has done it before. It will do it again. The question that the historical record, the federal risk assessments, and the grid vulnerability data all converge on is not whether it is when, and whether the person experiencing it had $200 and 2 hours to spend beforehand. Most people will not spend them. Most people will wake up tomorrow, reach for their phone, check the weather, and not think about any of this for even a single second. But you just did. That is the difference between the person who watched this video and the person who didn't. You now know what the grid is actually made of, what it cannot survive, what your government's own agencies have documented and not acted on, and exactly what 4 steps stand between your household and the most foreseeable infrastructure failure of the next 50 years. You are not the person who panics when the lights go out. You are the person who already knew they might. If that changes how you move through the world, subscribe. The people who understood the system before it failed were never the ones who panicked. They were the ones who prepared quietly, early, and completely. History remembers them differently.